Thanks for plugging in. Today we're talking excellence with TE Connectivity and the interconnect specialists from TTI IP&E. It's the news, information, and detail you need to know to stay informed about the latest innovations in all types of electronics connectivity. And now, here's your host, TTI's Scott Stemley.
Thanks, Jim, and hello, everybody. Great to have you tuning in to our next series of Talking Excellence with TE and TTI. In the studio with me today is TTI's Gabe Osorio, the Director of Transportation Marketing for the Americas. We're going to learn about high voltage solutions for an electrified transportation future. With us is Eric Brown, Director of Product Management, E-Mobility for TE Automotive. Thanks for spending time with us, Eric. Please tell us a little bit about you and your career at TE.
Yeah, absolutely. Appreciate the time. Appreciate you both having me here. So I've been at TE a little over 11 years. I actually originally joined through acquisition of a small sensors company. So the first 10 years of my experience in TE were both automotive and ICT. So off what we call ICT or off-highway, on-highway related. And about a year and a half ago, I moved over to be full-time in our automotive business unit. And I currently head all of our electric vehicle business for the Americas region.
Excellent. Okay, so as I mentioned, we're going to talk this series or this episode a little bit about high voltage solutions in an electrified transportation future. So first point to address is, how is the move towards high voltage systems shaping the design and function of vehicle architectures across the various transportation sectors?
Well, I think the first thing we can all agree on is this is a nonlinear path for everyone, and it's nonlinear path within our industry. So what we're seeing right now is there is a clear industry trend towards 800 volts or even beyond, but we're also now seeing some of our OEMs work to carry over 400 volt systems due to either component reuse directions or EV uncertainty. In terms of the design and how TE is positioning our portfolio, specifically on high voltage interconnects, is really figuring out how to position the products to meet our needs where their customers are on their journey. I think this is important because every customer is different. They have different goals, and that impacts the high voltage interconnects both on their current carrying capability as well as the need to be conductor agnostic. You have a difference in the industry right now from people using types of cable from copper to aluminum, all the way from different types of bus bars. So as the end of all those interconnects, we need to make sure that we can accommodate all of those different conductors. The third point that I'd bring in here is just the why for high voltage systems. I think one of the main goals for high voltage systems is to really enable quicker charging. We have all been conditioned to think, it takes 45 minutes, an hour to charge our car. The reality is that it actually takes 10 seconds just to plug it in. So this new high voltage system will definitely enable it, but I think it goes hand in hand with how we're training our customers and consumers to deal with electric vehicles.
Yeah, it's really interesting. Eric, do you think, especially on the charging side, I guess the perception or the thought that it needs to be done in 5 or 10 minutes or something along those lines, right? For there to be more broad scale adoption, specifically in passenger vehicle. But do you see, you talk about the ever increasing power that's associated with that. Are we at a place now where the power side of things is there to enable broad scale, fast charging capability? Obviously there's an infrastructure side to that needs to be addressed, but certainly from just the technology, the components, et cetera, are we where we need to be in your eyes to enable that, I guess, in the marketplace?
I would argue definitely yes, Gabe. I think that if you look at, again, I'll point a little bit to the automotive, but the average person travels about 40 miles a day. But we're fascinated with how much battery we can get in our cars. So I think now, especially with this move between 400 and 800 volts, when you combine that with the cost of the vehicles coming down, now whether that's on highway, off highway, or even passenger car, the technology is there. The price point is about to get there. I think the consumers will end up speaking with their wallets, and between those two factors, it should start to increase adoption, where then you don't have to have these government mandates or incentives essentially to drive it.
Yeah, that's a great point. It's interesting you point out that the average rider or driver drives 40 miles a day. But yet, when you see your ads for new EVs, they keep talking about longer and extended battery packs and, longer range, et cetera. But really, that's just addressing, I think, a concern that lives internal to the consumer. But great point there.
Yeah, well, it's essentially the horsepower wars we went through in the 60s, right? It's your battery mileage is your new horsepower war.
That's exactly right. Yep. So you mentioned 800 volt, right? That kind of brings me to the next point is, within the high voltage solutions, what advancements are taking place today, that are being pursued or designed to manage these kind of unique challenges of high voltage and high current, especially when we're talking, 800 volt, 1,000 volt, maybe in an off-highway vehicle or something along those lines?
Yeah, I think I would start with the core challenge of, again, we're reinventing our vehicles for the first time in over 100 years. And it doesn't matter what industry you're in, we haven't really settled on the perfect solution, right? You could kind of argue we've got the perfect internal combustion engine. We haven't gotten there on EVs, whether it's the motor or the battery architecture. So one of the things that we're focused on in our design environments as we get to high voltage is safety first. So the higher voltage really means that we have to protect for the person that's assembling it in the factory, the end user that's driving the car around or large piece of equipment around every day, or even the service tech. So one of the advancements that we've come up with and pioneered is safe touch bolted connection systems through what we call our Beacon Plus kits. And what that enables is that even a small finger, you can't have access to essentially the voltage. So a lot of the higher voltage requirements are driving the need for safety. I think the other thing to keep in mind is the assembly is becoming very different. So one of the challenges of high voltage, especially in the first generation, is you're now dealing with big wires that don't want to bend. So for a lot of our portfolio, including things like HC Stack portfolio, which is our high voltage interconnect system, we really focus on alignment features and mating force that help enable that easier assembly for the people that are either installing the things the first time in the factories or the service technicians.
It's interesting that you bring up assembly and service in a previous podcast episode for this series. That came up, the assembly side of that came up as well too, and that's not something I think that most people think about in the design process, right? Certainly, obviously, at your level or at the design level you are, but it's somewhat of an afterthought after all of the engineering requirements, right, or the technology requirements that are needed. Thinking about
ease of manufacturability,
right, or serviceability, right, when you need to service that battery pack or something along those lines. So, yeah, thanks for that, Eric.
Well, and you're seeing a very different trend when ease of manufacturability does not equal ease of serviceability, right? And I think you're now seeing, especially with an established dealer base, whether it's on highway, off highway, or passenger car, you're seeing those people get a lot more voice in how it's manufactured because they're the people that have to deal with it 10 years after it's been sold.
Yeah, the classic, you have to tear the complete car down just to change out a seal or a bearing or something like that, right? Yeah,
exactly.
Yeah. Let's pivot a little bit to charging infrastructure gaps. How can innovative charging inlet designs meet the scalability demands for the growing electric vehicle infrastructure, both in public and or private sectors?
Yeah, I think in terms of, again, first is safety. When you're dealing with this much voltage and this much current, safety has to be first. And one of the more innovative features on most of the charging inlets is what we call a finger cap protection. So when you look inside your charging inlet, it's the little black things that are on top of the pins, right? Larger scale means there is more opportunity for more misuse on both the plug and the charging inlet side. So a lot of our design features that we've had to put into this finger cap protection are really how to make sure that it doesn't come off. So the robustness of that safety critical item in the design phase and the test phase, really to help the end consumer make sure that it doesn't become an obstruction and become a failure leading to a thermal event. I think the other thing here in terms of charging inlet designs, predominantly passenger car, but then a little bit now off highway, is the settling on a industry standard like NACS or the megawatt charging. Because again, as you're looking at interrupting a consumer behavior, the more hurdles you put in front of them, the less likely they are going to be to adopt that. So now that we're in a situation where, okay, there's a common charging design, and what you're going to plug into, you likely in the future will not need to deal with an adapter. I mean, imagine using your cell phone, and we've all done the Apple to Android kind of dance, right, on charging your cell phone. It's the same thing on the vehicle, where if you have to take that next step of, I need to put something in between these two things to make it work, it's just another barrier for you to say, yes, I love it. It actually helps my life.
The standardization that you're talking about, the MCS or the NOx, has that helped you as the manufacturer now focus more on the design or technology development that needs to take place now that we have quote unquote a clear vision, right? Maybe of where that standard needs to move or is moving?
I would love to say yes, but in the interim, no. And the reason that I say that is, so the way that we design our charging inlets is we do, of course, platform them, and we platform them for global standards like GBDC and others, right? But for NACS, what it actually left us with in terms of partnering with our OEMs is you needed to build a bridge solution, because a lot of times, whether it's a giant truck or even a body in white, they're not willing, or they can't change those. And so we were actually left with almost a retrofit solution in many cases until we can get to the ideal, let's say, NACS interface. Unfortunately, that drove a little bit of design issues and complexity, but ultimately we do see it, to your point, settling in on a cost-effective solution that we can apply across the board.
Yeah, that makes total sense. Along the same lines, obviously, we're talking high power, high voltage, high amperage, in these systems and in the products that we're discussing. Thermal management certainly has to be, along with safety, I'm sure, a major design
Absolutely.
concern or thought, right? What solutions are you seeing being developed to address, thermal management in these new high voltage systems to ensure long-term safety and overall use, right?
Yeah, I think it's a good point, especially when you get into things like shielding, where you're trying to keep EMC in, right? But ultimately, you're also keeping some heat in. So that's a different complexity when you start to get into thermal management. But the two items I would highlight mainly are material selection in the design process, and then also how the external sources of thermal management inside the vehicle are operating. So from a material selection, of course, we do modeling. We also do a lot of extreme power usage, because a lot of times when you're developing a connector or a header or even a charging inlet, it's not the initial voltage, right? It's the extreme conditions that you have to design for. So we're doing a lot of that modeling up front before the design. And what it's also driving us towards is different types of materials. So for example, we're using a lot more V0 material now than we used to really help protect the consumer in the most extreme events. On the external side, from thermal management, I think you have to start looking at all of these other systems that are being adopted in EVs. So active cooling in the battery, power electronics, electric motor. All of these types of things really help enable those higher voltages and faster and quicker and safer charging as well.
Yeah, that makes a lot of sense. Yeah.
So fleet impacts, looking at these high voltage systems across different industries such as, logistics or agriculture, public transportation, again, not typically past car, but, how does the electrification impact play in those adjacent industries?
Yeah, it's definitely increasing. I think the biggest benefit to EVs as a whole is really your increased uptime, right? Like you're able to get more torque out of your motors. You have less moving components, less potential to fail. That is a huge benefit to a lot of these other adjacent industries. I think it's also enabling these other industries to come up with new powertrain solutions. So a lot of the e-axle type architecture that's being applied, whether it's in a long haul rig or on a piece of agriculture equipment or even trailers, those become critical because you're able to boost your fuel efficiency by potentially up to 30%, depending on the application. So taking those and figuring out how to get our product portfolio, the designs that we use to meet those vibration requirements as well as the carrying capabilities become a really interesting design challenge that our teams have had to go through.
Yeah, that's very interesting. Do you think, Eric, in terms of, I really think about public transportation and maybe more last mile delivery, something along those lines, being, the kind of ripe subsegments in transportation for electrification just based on consistent routes or a very timed process that they go through in terms of how much they're used and being used consistently over and over again. Do you think it seems like, maybe I'm trying to get to the question, I'm sorry, but it seems like that market has somewhat slowed down, or it's taking longer to adopt even more broad scale, especially in, I think, public transportation. Do you think that that's tied more to, regulation and what municipalities need to do to invest in that? Or do you think it's more of a technology adoption issue or concern that some fleet owners or fleet managers might have?
Yeah, I think it has to be cost in my mind, Gabe, because that's like when you're looking at, I need to replace a fleet of buses, right? If your cost is 20% more and you have to invest in the infrastructure, as short-term sighted as it may be, you're not going to pick that option. But I think your overall point is extremely valid, that the best use cases that we have for EVs are the ones where your route is very predictable, right? And that's going off on a small tangent here. That's also going to be your best use cases for driverless vehicles, right? And your EV vehicles are more able to be adapted to driverless cars than our internal combustion engine. And so I think as you start to get into like especially small autonomous delivery vehicles, of course, all of those are going to have to be EV. And that's where you bring your cost way down because you're not, adding a battery pack to carry the battery pack kind of equation. So the small last mile delivery, potentially autonomous vehicles, that's where I think we're going to get a lot of adoption as we start moving forward. And it'll be quick because your cost basis is very much lower there.
Yeah, no, that makes a lot of sense. So all of that said, Eric, how, and it can maybe kind of ties back to the question I just asked, right? Is industry-wide scaling, and how do we enable, or how is the industry going to enable the deployment of more high voltage solutions, extending outside of passenger vehicle, right? And I think you kind of maybe started to address that a little bit there, but how do we scale this, or how is it going to get scaled faster and broader?
Yeah, I come back to the consumer decides. So we have to get to a point where we are actually building the more efficient system. And when they put them next to whatever the equivalent is, the benefits will outweigh it, right? So if you take a Class 8 truck, right, and you put two of them side by side, if you can say, look, these are cost neutral investments for you, or even if, maybe the Class 8 truck that's electrified to some extent maybe it costs 10% more. That equation will pay off for them in under a year, right? So I think we have to get to the point where at least the architectures themselves become a small cost delta or cost neutral. And what we've seen evolve with our customers over the past few years has been very interesting, because a lot of times the first or second revision of a vehicle, regardless of industry, is way overspec'd, right? Because everyone wants to be very conservative and they want to make sure that it's a safe product. And that's a fair and valid approach. But as you learn more, you realize that your overspec'd also means you are overcosted, right? Because you're designing for features that your use cases aren't actually touching. So what we've seen is generation over generation, as every company is on this journey, they start to realize how they're positioning and that a lot of their own specs are what's driving the cost. So now that we've gone through education cycles, both ourselves and with our customers, we are seeing much more appropriate specs come across for the components, even with this increase in voltage. And we're getting to a point where we're able to partner and really develop that cost-effective solution that enables that adoption.
Yeah, that's very well said. So here's the one final hard-hitting question that I have for you, Eric, is, are you an adopter yet? Have you gotten your own EV?
I am not. I am not. And I am not an adopter because I am super cheap. So
back to that cost thing, right?
That's good.
Yeah, you want to go back to the overall market, and you've got the average, car payment right now is north of 700 somewhere. It's very painful for most families, but
it's unbelievable. Yeah.
I will say that on the other side, I do drive very efficient vehicles. I won't name the brands, but we have discussed, because if you talk passenger cars, most households in America are a 2-car household, right? We're very unique a market when it comes to that. The fact is that, like my garage, I have a car that's mostly a city car, and then I have a car that's long haul for the family. And it's very easy for us to look at that and say, well, yeah, that one should be electric because it does benefit, right? I think when we, as a consumer, whether it's, I would say this is mostly a passenger car comment, when we get real about the data around the usage of our vehicles, right, we tend to buy cars for the thing that we want to do less than 5% of the time, not the thing that it does 95% of the time. So I will be pretty clear, my next vehicle will be electrified to some extent. Will it be a full-on EV? I don't know.
I tend to agree. Yep.
Well, Eric, thank you for your insights and spending time with us today. That was really, really informative. And Gabe, I want to thank you for joining us in the booth today. Really great conversation, and again, look forward to our next time.
Absolutely.
Eric, before we let you go, any parting comments?
Appreciate the time. The one parting plug that we talked a little bit about adoption, and I've made this point. I want to make sure I continue to socialize it. A lot of adoption is about fear. And we talk about, needing to invest in charging infrastructure, needing to invest in the other thing. Awareness can be our biggest tool as we go through this journey. And so one potential solution there that I will always plug is, instead of spending millions of dollars to adding all these new charging infrastructures, simple signage on our highway systems and around our towns that can ingrain in daily life will really help the end customers start to adopt. So I'm all for the best ROI, so I will continue to plug that. But again, I think we're all on this journey together. Eventually it will get there. I travel a lot abroad. I will tell you, everyone else is already there. So it's really up to us in our region to figure out how to catch up together.
Yeah, got it. Well, thank you to our listeners for plugging in. If you learned something about vehicle architecture, next generation vehicle architecture, be sure to keep an eye on TE Connectivity and their advancements in these critical applications of our times. For more insights on this topic, visit our Transportation Resource Center at tti.com/marketeye. Until next time, I'm Scott Stemley, and this is the Talking Excellence with TE and TTI.
That's it for this episode of Talking Excellence. Join us next time for the podcast that brings together the specialists of TTI with the connectivity experts from TE, an insightful conversation about getting connected.